In pursuit of transferring technical knowledge and just to gear up for the new engineering entrant, myself Pranav is here to deliver today's presentation, Power Transformer Part 63. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Now, let's start with basic characterization of aromatic hydrocarbon in crude oil. Naphthens or cycloparaffins or cycloalkanes may constitute with the rings or cyclic saturated hydrocarbons, and that have at least one ring of carbon atoms which composed of a general formula CnH2n. Again, I repeat, naphthens or cycloparaffins or cycloalkanes may constitute with the rings of cyclic saturated hydrocarbons and that have at least one ring of carbon atoms which composed of a general formula CnH2n. Aliphatic hydrocarbons would constitute with the absence of benzene ring, whereas aromatic hydrocarbons may have to possess a benzene ring. Aliphatic compounds are alkanes which only have to contain carbon-carbon, that is CC single bonds. So, in organic molecules of aliphatic compounds, there would never contain any sort of CC double or triple bonds. Most important. Aliphatic compounds that might be different structures such as cyclic, linear, or even branched. The absence of multiple CC bonds in the structure of aliphatic compounds would therefore be represented as the most distinguishing feature. Aromatic compounds would have the cyclic molecules that contain alternating single and double bonds. Aromatic hydrocarbons are nonpolar and relatively non-reactive type, where benzene is the most common aromatic compound present in crude oils. Aromatic compounds, as constituted of the low hydrogen to carbon ratio, so the composition structure would contain a large number of double or triple bonds. Aromatic compounds are thus to exhibit a high degree of chemical stability compared to alkanes and cycloalkanes, saturated aliphatic compounds. Aliphatic hydrocarbons would be the most abundant fraction in crude oil whose molecules are linear or branched open chain structures rather, such as N-alkanes, isoalkanes, cycloalkanes, naphthenes, etc. Aliphatic hydrocarbons may be of saturated or unsaturated hydrocarbons with having double carbon bonds. However, saturated and unsaturated hydrocarbons that would have to depend on the type of bonds they contain. Saturated hydrocarbons should contain only single covalent bonds, that is alkanes, whereas unsaturated hydrocarbon would contain at least one or more double CC bonds, that is alkanes, or triple CC bonds, that is alkynes. Due to the presence of multiple bonds in unsaturated hydrocarbons, which would make these hydrocarbons much more reactive than the saturated hydrocarbons. Again, I repeat, due to presence of multiple bonds in unsaturated hydrocarbons, which would make these hydrocarbons much more reactive than the saturated hydrocarbons. Unsaturated hydrocarbons would therefore be more susceptible to attack by other molecules, whereas saturated hydrocarbons would have been less reactive as the hydrocarbons are less likely to form covalent bonds. Saturated hydrocarbons are commonly referred to as paraffins or alkanes, which are the most stable and abundant hydrocarbon constituents of crude oils. Unsaturated hydrocarbons are commonly referred to as olefins or alkanes. However, olefinic hydrocarbons, that is olefins, are not naturally occurring constituents of crude oil. Normally, olefins that would have been produced during the active process of the crude oil refining cycle. Aliphatic saturated hydrocarbons with low molecular weight would be of liquid or gaseous form, which include methane, that is CH4, ethane, CH3CH3, propane, that is CH3, 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 and butane, CH3, C2H4, CH3. Perhaps in most of the crude oils, the absolute amounts of aliphatic hydrocarbons with high molecular weight are found to be quite small, which may generally be of the order 0.5 to 2 weight percentage. These crude are commonly referred to as the high wax crude oils. Evaluation of crude oil characteristics. Elements present in crude oils would thereby form a large variety of complex molecular structures and thus to depend on the actual variation in propositions rather of these constituents, causing a wide change in chemical as well as physical properties of the crude oils. In normal case, crude oils that are often to be categorized on the basis of chemical composition as constituted by the proportion of hydrocarbon contents. There are different classes of hydrocarbons which would be the bulk of the constituents present in crude oils. So, crude oils are thus to be characterized by the molecular distribution of individual hydrocarbon composition along with the presence of sulfur content. Apart from all sorts of variants, it has been evaluated that most of the crude oils, as being composed of hydrocarbons, may have to compose with the possible range of 12 to 15% hydrogen by weight and 82 to 87% carbon by weight. Most important, 12 to 15% hydrogen by weight and 82 to 87% of the carbon by weight. The non-hydrocarbon compounds such as sulfur, that is about 0.5 to 3% by weight percentage. Oxygen, it is less than 1% by weight, and nitrogen is less than 1% by weight. Though their level of concentrations are very low, but still would have a strong influence on the crude oil composite characteristics, out of which sulfur is the most critical component. The level of sulfur content of 1% or more by weight present in crude oil, either as elemental sulfur or as in compounds, that is hydrogen sulfide, etc., would be other alarming, would be rather alarming, and needs to extract from crude oil during refining. Through analysis, it has been established that heavier crude oil generally would have a higher percentage of sulfur by weight. Specific gravity is therefore be the most important physical property through which crude oils can be classified as heavy, medium, and light. API gravity equation. The physical properties of crude oils that would have to differ substantially as due to variation of chain length of the constituent hydrocarbons and additional components such as sulfur. During production of crude oils, the classifications such as heavy, medium, and light can be evaluated by determining the values of density, specific gravity, and API gravity. All these parameters are to be really measured in accordance with the process as recommended by the standards ASTM D5002 and ISO 12185. The American Petroleum Institute, API, has standardized a unit for the liquid fluid called as API gravity. Specific gravity and API gravity both have used to compare how dense a petroleum liquid is. The American Petroleum Institute, API, has adopted the process by which to provide a standard way of measuring the density of crude oil and liquid hydrocarbons. The API gravity scale is based on the principle of comparing the weight of a given volume of liquid hydrocarbons with the weight of an equal volume of water. The density is so far been measured as mass per unit volume of a fluid and is to have a temperature dependent property. The density of crude oil of liquid hydrocarbons is usually reported in terms of specific gravity or relative density, where specific gravity would have to decrease with the increasing temperature. It is as because that the volume of a petroleum liquid would have to increase with increasing the temperature. So, the density must have to be measured at a given temperature, and according to the API standard, the measuring temperature is 15.6 degrees centigrade, that is 60 degree Fahrenheit. Therefore, specific gravity of liquid hydrocarbon is equal to the density of liquid hydrocarbon at 15.6 degrees centigrade divided by density of liquid water at 15.6 degrees centigrade. Density of liquid water at reference temperature 15.6 degrees centigrade is 0.999 grams per centimeter cube. Specific gravity of liquid hydrocarbon equals to density of liquid hydrocarbon at 15.6 degrees centigrade divided by 0.999 gram per centimeter cube. The measuring scale of API gravity is calibrated in terms of degrees API, that is degree API, and to be calculated from the following equation. API gravity, that is degree API liquid hydrocarbon, equals to 141.5 divided by specific gravity of liquid hydrocarbon at 15.6 degrees centigrade. In contrast to relation of specific gravity and temperature, the API gravity scale that has to increase with the increase of temperature. Heavy crude oil would have been referred as an API gravity less than 20 degree, and the crude oil having an API gravity less than 10 degree is referred to be extra heavy crude oil. তাহলে heavy crude oil is API gravity is less than 20 degree, and the crude oil having API gravity less than 10 degree is referred to as extra heavy crude oil. As compared to lighter grade crude oils, the physical properties that have to differ in case of heavy crude oils, which include the higher viscosity and specific gravity, with having the hydrocarbon composition of higher molecular weight, extra heavy crude oil would have to correlate with the various physical and chemical properties of the natural or crude bitumen having a viscosity greater than 10,000 centipoise. 1 centipoise equals to 10 to the power minus 2 poise, that is 0.001 kg per meter second. The API gravity measurement would have a significant role in determining the quality assessment of the crude oil. However, along with viscosity and API gravity, there would have the much importance to verify the hydrogen and carbon atomic ratio, oxygen and carbon atomic ratio, volatiles, composition of hydrocarbon compounds, as well as presence of sulfur content in crude oils. Through API gravity measurements, the refineries would able to optimize their operational as well as processing techniques of refining the crude oils with having temperature oriented different composition and their chemical characteristics. Most important, the lighter and less dense crude oils, which would have the higher API gravity values, are often to be considered more desirable in high value industrial application. That is, cost of the lighter or less dense crude oils is much higher as compared to heavy or extra heavy crude oils. Criteria for determining the crude oil quality assessment. Many types of crude oil with different quality characteristics are produced around the world and to be categorically distinguished by their respective underneath elemental compositions. See, the elements in crude oil, that is carbon, and its composition, that is composition in weight in percentage, 83 to 87. Hydrogen, 10 to 14. Sulfur, 0 to 0.05 to 5. Oxygen, 0.05 to 2. Nitrogen, 0.1 to 0.2. Nickel, it is less than 120 ppm. Vanadium, less than 1200 ppm. Sodium, 20 to 2000 milligram per kg of crude oil approximately. Now, crude oil composition, therefore, is a mixture of hydrocarbon compounds, as for example, paraffinic, naphthenic, and aromatics. Number two, plus small amounts of organic compounds of sulfur, oxygen, and nitrogen, plus small amount of metallic compounds of vanadium, nickel, and sodium. Classification of crude oils. Paraffinic base crude oils. Crude oil is called as paraffinic if the distillation residue would contain more than 5% wax. Then it is called paraffinic base. Asphaltic base crude oils is called as asphaltic if the distillation residue would contain less than 2% wax. A significant residue would primarily be asphaltic, that is, predominantly condensed aromatics, containing relatively a higher percentage of sulfur, oxygen, and nitrogen. High percentage naphthenes is commonly present from the light and intermediate fractional distillation residue. Aromatic base crude oils, where the content of aromatic compound may have up to 80% of the total constituents. Mixed base, that is, contains a mixture of considerable amount of both wax and asphalts. The characteristics of crude oils that would have to vary mainly because of the variation in their basic internal composition, which corresponds to have different proportions of various molecular types and molecular weights and hydrocarbons. Classification of crude oil that would have to be determined through evaluating three of the most critical characteristics such as density, sulfur content, and total acid number, that is tan count. Crude oil viscosity is one of the most important physical property which must have a strong function with temperature, pressure, specific gravity, degree API gravity, and hydrocarbon composition of the oil. Crude oils containing low carbon, high hydrogen with having high API gravity are usually rich in paraffins and are to be most preferable for producing light petroleum products. Whereas crude oils containing high carbon, low hydrogen with having low API gravity are usually rich in aromatics. The Pour point of crude oils is another important physical property where it would be a temperature point at which the oil has lost its flow characteristics capability under gravity. However, determination of viscosity and pour point that would rather ascertain the flow as well as handling characteristics of crude oil under the corresponding condition of low temperatures. Crude oil containing sulfur elements in the form of aliphatic and aromatic organic sulfur compound would be the real concern as the major impurities. Hydrogen sulfide H2S is the only most dominant inorganic sulfur compound found in crude oil, which is really harmful because of its corrosive nature, whereas organic sulfur compounds may generally be classified as acidic and non-acidic, and their adverse impact should therefore be technically identified during the crude oil processing cycle. Let's stop here, further to be continued at later stage. Thank you. Thank you for listening the video. Kindly do like, share and subscribe. Your subscription would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.